Let's see if we can solve a quadratic equation where the leading coefficient is not 1 by factoring. The first thing that we know is we want to get our quadratic to be equal to 0. So in this example, I'm going to have to add 15 to cancel out and bring the right side to 0, and then I have to add 15 to the left side. What is that going to leave me with? It's going to leave me with 3n squared minus 46n plus 15 equals 0. And once I set my quadratic to 0 and I factor it into two binomials, I know that I can set each of those binomials to 0 in order to solve. And we'll just talk about why that is in a minute. But let's tackle this factoring. So I'm pretty good at factoring when the lead coefficient is 1, but here we have a 3 as the lead coefficient. And so this is a new method that I've actually learned it on YouTube. So thank you, YouTubers. I'm going to multiply I'm going to multiply A times C. Okay, so in this case, A is 3 and C is 15. So I'm going to get the product of that, and 3 times 15 is 45. And I am going to think of all the factor pairs for 45. And my goal, my focus, is to get two factors that can give me 46 as a sum. So that's going to take care of my middle term, and you will see that the 46 here is negative. So what I'm going to have to do is my factors are both going to have to be negative because they have to have a negative sum, and they have to have a product of 15, and we know that a negative times a negative is a positive. So first let's get the absolute values of the factors, and then we'll deal with the signs. So what do I have? I have 1 times 45. I have 5 times 9. And I have 3 times 15. And again, I know that the sign for both of these factors are going to have to be negative. So let's look at the possibilities and see which can give me a sum of negative 46. And I'm looking, and right away I see that 1 and 45 are 46. So I'm going to use negative 1 and negative 45. And what I'm going to do is I'm going to break this down, this middle term, into these factors. So it's going to look like this: 3n squared minus n, that's the factor of 1, so it would be minus 1n, plus, well, actually I'm going to do minus. I could do plus a negative, but I'm going to do minus 45n. So minus n minus 45n is going to give me a sum of minus 46n, plus the 15, and that's going to be equal to 0. Now what I'm going to do is I'm going to try to get two binomials from here. So I'm going to look at the first two terms, and I'm going to factor out the greatest common factor, which is going to be n. And when I factor out the n, it's going to give me n times 3n minus 1. And then when I factor this second pair of terms, the greatest common factor is going to be 15. I'm going to make it be negative 15 because, well, we'll see in a minute. So negative 15 times 3n minus 1. And the reason now you can see is, the reason I pulled out the negative 15 is that I want to be able to have one factor in common here. So if you see, when I factored these terms, I have 3n minus 1 here, and I have 3n minus 1 here. So I'm going to use that as a factor. So I have 3n minus 1. And my other binomial is going to be just taken from these outside terms, the terms outside of the parentheses, which is n minus 15. And so here I have my two binomials, and I'm going to set each one to 0. So I have 3n minus 1 equals 0, and here I have n minus 15 equals 0. Why? Because I know that if one of these things is 0, 0 times anything is going to give me 0. So if I set one factor to 0, my whole equation is going to be 0. So let's solve each one of these. So I have to add 1 to both sides over here, and I get 3n, this cancels out, equals 1, and I'm going to divide by 3. So I have n equals 1/3, and that's one of my solutions. And the other solution is going to be, I'm going to add 15 to both sides. This will cancel out, n equals 15. And so the solution to my quadratic is 1/3 and 15. And that's kind of a neat way of solving quadratics by factoring when the lead coefficient is something other than 1.